So far, we've really focused on understanding a derivative in terms of its algebra and in terms of its words, but how does it work graphically, right? So I have a position function shown, and we want a graph of the speed function, right? The derivative of s, of the position function. Okay, how do I do that? Well, remember that if from, so s prime, right? That was the that was generated by the tangent lines, okay? Or rather, if we looked at the average rate of change of the s of t function and we did a limit of that, that was then the instantaneous rate of change of the position function, or the instantaneous speed, right? And so these were secant slopes. And then the whole thing, when we did the limit, that was the tangent slopes. Okay, so what I'm going to do to generate the graph of s prime is pick, just for right now, I'm going to pick a bunch of points. Okay, and they're seemingly a little random. Okay, and what I'm going to do is look at the tangent slopes of the slopes of the tangent lines at each of these points that I drew, just to have an idea of what the derivative value might be. And so if I look at this first one, right, the slope of that tangent line, it's positive, right? And so maybe, let's say it's positive, it's not terribly positive, but maybe it's there. Okay, I have no scale on my vertical axis. Next one, it's still a positive slope, but it's less so, so maybe like right there. That one's pretty close to 0. So maybe right there. So I keep sort of the x position, but now the y position becomes the slope of the tangent line. Okay, so this one, the slope is negative, so keep the x position, but then negative here, and this is more negative. Okay, and even more negative, and even more negative, so something like this perhaps. Okay, so little wavy, but again, I'm kind of guessing here. And then I can connect these to estimate what s prime is. But what I end up doing is, again, looking at the slope of the tangent line at each of these points and kind of piecing them together to get an overall sketch. Okay, and then just note that there are instances where the derivative does not exist. If we have something like a cusp or a sharp corner, it would look, a cusp would be looking something like a bird or like an absolute value graph. Discontinuities, we would have something like, like this, and we have a jump like that, and vertical tangents, very rare, but you sometimes see them happen when we have like radical functions. But again, here, if we look at, the derivative, right, this tangent line slopes would be negative and then suddenly switch to positive, right? Here, we would have tangent slopes and then, well, how do we do a tangent slope there? And then here again, kind of positive slopes or 0, and then, well, bam, we jump, and then it's like a gap, and then we'd have, maybe positive slopes again, okay? So with that idea, we have an example where we just kind of have to piece things together. We have to figure out what each of these, so there's 4 functions shown. One of them, it says, is the position or displacement function, and then another is velocity. Acceleration is the second derivative of displacement, and then jerk is the third derivative. So we have to figure out which is the function, first derivative, second derivative, and third. Okay, and so I'm just going to make that note. So we have displacement, which is s, we have velocity, which is s prime, and we have acceleration, which is s double prime, and we have jerk, which is s triple prime. Okay, so again, I want you to pause the video and try this on your own, and again, see if you can determine which is the original function and which are the derivatives. And again, keeping in mind that to find the derivative, the graph of the derivative, we have to look at the slopes of the tangent lines at several different points. Okay, so pause the video right now, try this out on your own. And if you were able to do this, what ends up being the answer is that we have d as displacement, and then c as the velocity, b, and then a. So what I would say is, if you're curious about trying this, okay, take several points again, just like we did here, okay? Start with d, and then we're looking at the tangent slope. So positive, 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 they're all positive, right? Except for maybe here it starts to become less positive. And so that's going to give us graph C, right? And then again, take points. Okay, so again, it's going to be positive, and then here it starts to flatten out-ish, and then maybe dip a little negative, so that's where we get B, and then A follows from that. All right, so there we go. We have at least a start to understanding how to graph the derivative of a function, in addition to how to find the derivative algebraically and also in words.